this lesson, we will see how to insert a point cloud in RCP format into the environment of the BIM authoring software Autodesk Revit. Point clouds, which are surveyed representation obtained through laser scanning instruments or photogrammetric techniques, provide an accurate 3D representation obtained through geolocated points of the surveyed state. BIM authoring softwares offer the possibility to import point clouds into their environment, integrating accurate geometric data of the real world with informational modeling. The process of inserting a point cloud into Revit requires an RCP format and a series of preliminary operations to define the starting model. We create a new project in Revit by choosing the template most consistent with the modeling discipline. In the video, as an example, the architectural template is chosen, and then we select the project option. Once the new project is open, in the Insert panel on the main toolbar, we select the Point Cloud option, which will open a dialog window for loading the point cloud. Inside the dialog window, we need to locate and select the desired RCP file to import. Once the file is selected, there are several import options, including positioning the point cloud within the Revit working environment. It is recommended to choose from origin to internal origin to ensure correct alignment of the point cloud origin with the project origin in Revit. We confirm the import of the point cloud, and Revit will proceed with loading and positioning the point cloud within the working environment. Once imported, we can explore the point cloud using Revit's navigation tools, including plans, sections, elevation, and 3D view. In the 3D view, you can tour the model with a view cube on top of the central window. Using the Visibility Graphics Override command, type VV on the keyboard, it is possible to adjust the color and visibility of the point cloud, allowing for better understanding and interpretation of geometric data. We can also modify the section settings to avoid selecting the point cloud during the modeling phase. Additionally, to prevent moving and modifying the point cloud, it is recommended to select and lock it using the lock command. Next, we address the phase of tracing the reference system of the model, namely the reference grid and altitude levels. This phase requires careful analysis of the surveyed work represented by the point cloud to establish a coherent and accurate reference system. Tracing the reference grid involves aligning the grid with the main axis of the building, thus providing a support structure for subsequent modeling and design. We access a plan view and activate from the architectural panel Grid tool from the View panel in the toolbar. Once the command is activated, it is possible to start tracing the grid by selecting specific points of the point cloud visible in the plan view as OSNAP. This allows users to align the grid with the main axis of the building or orient it according to the specific needs of the project. After tracing the grid lines, it is possible to adjust the properties of the grid, such as the distance between the lines and the style of the lines. Once the grids are modeled, it is recommended to select them and use the lock function to prevent modification. This ensures that the grid lines remain fixed and do not undergo involuntary changes during modeling activities. Additionally, it is possible to manage the visibility of the grid lines through the Visibility Graphic Override command, type VV on the keyboard, for example, hiding the grid lines to simplify the visualization of the plan view. Once the reference grid are set in the plan view, it is possible to create vertical sections that allow an altimetric visualization of the point cloud. To create a section, it is necessary to access a plan view, Then activate the Section tool from the Quick Access toolbar in Revit and define the position and orientation of the section within the selected view. Additionally, it is possible to modify the depth of the section by adjusting the horizontal clip offset parameters from the Properties panel of the created vertical section. At this point, it is necessary to create the different levels required to define the various elevations of the building. The levels represent the horizontal surfaces to which the different architectural elements, such as walls, floors, and ceilings, will be aligned. It is possible to use the Level tool from the toolbar and define the elevation and name of the desired level. In this case, it is also recommended to lock both the levels and the modeled element using the lock command. Once the tracing of the reference grid and altitude levels is completed, we can proceed with the next phase of the modeling process. This integrated work approach with the point cloud allows for greater accuracy in the modeling process, minimizing errors and discrepancies between the model and the existing work being surveyed.